understood addition and subtraction on the number line. Multiplication, however, takes us up from the line to another dimension. Let's think about a multiplication problem. Say we want to know what 5 times 3 is. Of course, thinking of it as repeated addition, this is 5 plus 5 plus 5. 5 plus 5 is 10. 10 plus 5 is 15. But let's think of a way to understand that visually. 5 plus 5 plus 5, of course, we could think of on the number line as 5 plus another 1, 2, 3, 4, 5, plus another 1, 2, 3, 4, 5 is 15. But that seems to somehow not make use of the fact that these are all the same number. What we'd like to be able to do is take our 5 and put another 5 underneath it, where we can see that they're the same length, and yet another 5 underneath it. Well, what if, instead of little line segments, we understood each unit as a little square? So we would then have 1, 2, 3, 4, 5. Adding another 5 would look like this, and a third 5 would look like this. See here, we have a rectangle. One side is the line segment 5. The other side is the line segment 3. This gives us a new understanding of multiplication. Multiplication is the operation that gives us the area of a rectangle. Now, what do we mean by area? We mean how many little squares does our rectangle cover. So, since this rectangle covers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 little squares, the area of this rectangle is 15, which is 5, the length of one side, times 3, the length of the other side. This model, this understanding of multiplication, is called the area model of multiplication. So based on this model, I'm going to ask you to do an exercise. On graph paper, that is, the paper divided up into little squares like this, or by drawing squares on your notebook paper, draw a rectangle with one side 4 squares long and the other side 5 squares long. Then use the area model to find 4 times 5. Now, even if you already know what 4 times 5 is off the top of your head, please use this method for this exercise. Pause the video and try this now. Okay, so I want to draw one side 4 squares long. This distance is 4. And the other side 1, 2, 3, 4, 5 squares long. This distance is 5. Fill it in so I've got a rectangle here. 4 times 5 will be the number of squares that this rectangle covers, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. According to the area model, 4 times 5 is 20. And why does that work? Well, each row has 4 squares. So when I count out the first row, I get 4 squares. The second row, I get 4 squares. The third row, I get 4 squares. The fourth row, I get 4 squares. And the fifth row, I get 4 squares. How many 4s is that? Of course, it's 1, 2, 3, 4, 5. So we are adding 4 to itself 5 times by the counting that I just did, which should indeed be 4 times 5.